Okay, so the question today is collecting numbers. I'm given an array that contains each numbers between 1 and n exactly once. My task is to collect the numbers from 1 to n in increasing order. On each round, I go through the array from left to right and collect as many numbers as possible. Well, what will be the total number of rounds? So we have our input, which is n, the array size. The next line has n integers from x1 to xn. And then we want to print one integer, the number of rounds. So we see here that for 5, we have 5 numbers. On the first pass, we can pick up the 1, and we can pick up the 3. I mean, no, we can't pick up anything. Just pick up the 1. And then next round, we pick up 2, and then we pick up 3. And on the last round, third round, we pick up 4 and 5. And then we're done. So that's why it's 3. Okay, so the idea behind this question is that simulating it would be too slow. That's not possible to do. So instead, what we want to do is see how many numbers. We want to compare the number before and to that number. And if there's an inversion between those two, then we know that we have to increase our counter by 1 because we need to switch it. Not for every one of the number because we're just trying to, because if something is out of order, then we would have to go one more time to pick it up. So then in the code we have include IOStream and include vector using namespace SCD, which is pretty standard. In our main loop we have iOS sync with Studio and cin.ty to make our input and output faster. Next we have our in and we input that in. We create a vector which is our containing our list of numbers. And because we want to know where it happens, we would want to put position rather than the value. So we use the value as an index and we store the position of it. So that's why in our for loop, we go from 0 to n. So like that's how we get our n numbers. We get the value and then we input the value. And then at the value place, we put in the index of where it is at. So that's how we get that, like the index. And then next, what we do is definitely we want to count how many inversions there are. Not necessarily of all the numbers, but just the ones that are next to each other. So we have integer in rounds equals to 1. And then in the for loop, I go from 1 to n, not including n because I only need to compare every number with itself, with the one before it. So then that means that I don't need to like actually go to the last, like I just go to the last one and I start off with 1. So then I just go through n minus 1. And then my if loop is if pos I plus 1 is smaller than pos I. So then that means that there is that inversion in front. So then I would need extra rounds. So then I increment my rounds. So that's one more. And then after going through the whole thing, which is O(n), we output the number of rounds and we just return 0 and we get what we need. Okay, that's it for today. I think the major thing with this problem is just realizing the fact that the uh you don't have to simulate the whole thing to know the answer. The minute you see an inversion between consecutive numbers, we know that it adds an extra round because we would have to go through the list again. Okay, cool. Let's stop it here.